Okay, so now we continue with the third type of passive transport, which are osmosis. Okay, so bila dia katakan berkaitan dengan osmosis sahaja, so dia akan melibatkan movement of water molecule. So water molecule will move from higher water potential region to lower water potential region across selectively permeable membrane. Okay, so how we consider? Okay, the water potential is higher or the water potential is lower. Actually, it is depends on the dissolving solute inside of the solution. Okay, so kalau awak tengok for this one, pure water has highest water potential value, which is the water potential. So you have to remember the symbol for water potential is psi. So the symbol is like this. So the water potential of the pure water is highest, which is it is equal to 0. Okay, so how to get the water potential? So what is the formula of the water potential? So water potential is equal to solute potential plus pressure potential. Okay, so kalau kita tengok based on this one, the water potential of the pure water is equal to 0. Pure water means in that water it does not contain any solute. So what happen if there is a dissolving solute inside of the solution? So the dissolving solute molecule into pure water will reduce the free water molecule. So means that bila ada dissolving solute, awak letakkan solute di dalam pure water tu tadi, so what happen, dia akan reducekan the water potential. So the water potential will become negative. Okay, so saya dah starkan dekat sini. Maksudnya solute will make water potential to become more negative. Okay, so now we look at the solute potential first. Okay, so what is solute potential? It is a measure reduction in water potential due to presence of solute molecule. Okay, so maksudnya if in the water, okay, adanya solute, so what happen? Okay, the solute will cause the water potential to become negative. So that's why the solute potential value always negative. And then the greater solute concentration, the more negative its solute potential value. Okay, maksudnya kalau misalnya di dalam sesuatu solution tu, solute concentration dia adalah tinggi, so apa yang akan berlaku adalah dia punya nilai solute potential pun akan jadi semakin negatif. Okay, and then solute potential will predict or measure the change in water potential with the presence of solute molecule. Okay, so this is for solute potential. So what is the difference with pressure potential? Okay, kalau untuk pressure potential, when water pass into a plant cell, the cell contents start to swell and push against the cell. Maksudnya bila ada air, okay, inside the plant cell, so what happen? The cell contents starts to swell. Okay, swell means mengembang, and then it will push against the cell. Okay, so the pressure that cell will develop called pressure potential. So selalunya kalau untuk pressure potential ni, dia akan exist in the plant cell. Sebab apa? Dekat plant cell tu dia ada cell wall. Okay, and then pressure potential value is always positive. Kalau kita compare dengan solute potential tadi, the value of the solute potential is always negative. But for pressure potential, the value is always positive. Okay, so macam mana kita nak fahamkan konsep of the water potential? Okay, so if you look at here, okay, so for water potential, let's say here it has 2 compartment, okay, and then the water potential for the first compartment here is negative 1000 kPa, while the other one, the water potential is negative 500 kPa. Okay, so how to determine which water potential is highest or lowest? We look at its value. So kalau awak tengok dekat sini, in the second compartment, the water potential is less negative compared to the compartment 1. So that's why in the compartment 2, it has high water potential, which is its value is less negative or 0. Kalau 0 tadi, dia adalah water potential untuk pure water. Why kalau kita bezakan dengan compartment 1 ni, okay, kenapa kita katakan dia punya water potential is lower? Because it has more solute. Yang warna merah ni adalah solute. It has more solute compared to the compartment 2. So bila solute tinggi, so dia akan reduce the water potential to become more negative. Okay. So that's why, okay. Kalau awak tengok dekat sini, untuk compartment 1, it is lower water potential because the value of the water potential is more negative. Okay, so dekat sini saya highlightkan more solute present. So the lower the water potential. Okay. Okay, so now we continue here. Okay, so remember what is osmosis? Okay, osmosis, it is the movement of water molecule from higher water potential region to lower water potential region across selectively permeable membrane. Okay, so macam mana kita nak fahamkan konsep of the water potential? So awak tengok dekat sini dulu. Okay, water potential of pure water is equal to 0. Okay, so saya starkan dekat sini. The dissolving solid molecule into pure water will reduce water potential or it will make water potential to become more negative. Okay, let's say you look at this diagram. Okay, so this is the pure water with the water potential is equal to 0. So what happen kalau saya tambahkan solute, okay, in this solution? Okay, so the solute will make, ataupun kita katakan dekat sini, the dissolving solute will reduce the water potential of the pure water. Daripada kosong tadi, bila adanya dissolving solute, so the water potential will become more negative. So let's say, for this one, the water potential of this solution, bila ada solute, so dia akan jadi negative 500 kPa. Okay? So, apa yang awak kena ingat adalah, so the greater the solute concentration, okay, so means that the lower the water potential. Okay, so kita tengok example dekat sini. Okay, so cell A and B separated by selectively permeable membrane. So let's say at the center here, it is the selectively permeable membrane. So this is the cell A, this is the cell B. So for both cell, it is already given the value of solute potential and also the pressure potential. So let's say untuk cell A, the solute potential value here is negative 1400 kPa. Its pressure potential is 400 kPa. While for cell B, okay, its solute potential is negative 1800 kPa, while its pressure potential is 600 kPa. So, remember, you have to know the formula to calculate the water potential. So, how to calculate the water potential? Water potential is equal to solute potential plus pressure potential. So that's why if the question asks you to calculate the water potential value for cell A and also cell B, so just masukkan sahaja di dalam equation. Okay, so the equation to get the water potential is water potential equal to solute potential plus pressure potential. So dah ada value dekat sini. So negative 1400 kPa plus 400 kPa, so you will get negative 1000 kPa. Okay, don't forget to write the unit. Unit mesti kena tunjuk. Okay, and then water potential for cell B. So, dari segi caranya sama sahaja. Firstly, this is the formula to find the water potential. Okay, so how to get? Solute potential plus pressure potential. So, solute potential here is negative 1800 kPa plus 600 kPa. So, the water potential of cell B is negative 1200. Okay, so macam mana kita nak determine which water potential is the higher? Okay, is the highest. Okay, so kalau untuk cell A tadi, it is negative 1000 kPa. While for cell B, the water potential is negative 1200. So, macam mana kita nak tentukan? Awak tengok yang mana value-nya adalah less negative. So, means that its water potential is higher. So, kalau kita compare in between cell A dengan cell B, so which one the water potential is less negative? Is cell A. Okay, so that's why bila kita tengok second question, the question wants you to state the direction of the water movement. Okay, kalau kita ikutkan dari segi the definition of osmosis, the water move, okay, from higher water potential region to low water potential region across selectively permeable membrane. Okay, so since water potential in cell A is higher than water potential in cell B, so water will move from higher water potential, which is from the cell A, to lower water potential, which is in cell B, by osmosis. Okay, so means that you have to know, okay, how to identify or how to differentiate which one cell has high water potential and also low water potential, and you have to relate it with the concept of osmosis. Okay. Okay, so now we proceed to this one. Okay, so for osmosis, okay, you have to know about the solution of different concentration. The concept of the osmosis, kita boleh relatekan dengan solution of different concentration. Okay, so there are 3 types of solution here. The first one, hypotonic. Second, isotonic. The other one, hypertonic. Okay, so you have to know how to differentiate, okay, what happened to animal and also plant cell if it is placed in hypotonic, isotonic and also hypertonic. Okay, so we look one by one. Okay, so first of all, okay, if you look at the hypotonic, so what is hypotonic solution? It has low concentration of solute. So means that di dalam solution of hypotonic tu, dari segi concentration of solute ni adalah rendah. Okay, and then it is a solution where solute potential is low. Why water potential is high? Because of what? Kalau concentration of the solute in this solution is low, so means that its solute potential also will be low. But what happened to its water potential? Its water potential will be high. Sebab water potential ni dia akan bergantung kepada dissolving solute. So kalau dissolving solute tu rendah, water potential tu akan jadi tinggi. Okay, and then water potential cell is lower than water potential in solution. Okay, so let's say ni adalah cell. Saya dah lukis dekat sini. So since the hypotonic solution, it has high water potential. Okay, so this solution has high water potential compared to the water potential in the cell. Okay, so what happened? Water from solution will diffuse into cell by osmosis. Because of what? Kalau kita relatekan dengan konsep osmosis, water move from high water potential to low water potential. So since water potential in the solution is higher than water potential in the cell, so means that water from solution will move into the cell by osmosis. So dekat sini saya tunjukkan ni adalah contoh untuk animal cell. So animal cell in this case is the red blood cell, and then the other one here is the plant cell. Okay, so what happen kalau kita nak bezakan? Okay, for plant cell, when water diffuse from solution into plant cell by osmosis. So since this is hypotonic solution, when you place the plant cell inside the hypotonic solution, so the water from the solution will diffuse into the plant cell by osmosis. So what happened to the plant cell? So plant cell will swell and become turgid. So you look at this one. So water will diffuse into the plant cell. So what happened to this plant cell? It will swell and become turgid. But if you compare to animal cell, what happened when water diffuse, okay, from the solution into animal cell by osmosis? Okay, so the animal cell will swell, okay, and lyse. So kalau untuk red blood cell, the terms we call as hemolyse. Dia macam pecah lah, dia burst. Okay, and then we compare to isotonic solution. Okay, so what is isotonic solution? It is solution that has the same concentration of solute as another solution. Okay, so what happen when a cell is placed in isotonic solution? Water move into and out of cell by osmosis at same rate. Maksudnya dari segi water movement in and also out of the cell is at the same rate. Dia dalam kadar yang sama. Okay, so what happened to the plant cell? Plant cell become flaccid and plant wilt. Kenapa keadaan ni boleh berlaku? Kenapa kita katakan bila plant cell awak letakkan dalam isotonic solution, the plant cell will become flaccid and plants wilt? Flaccid ni maksudnya dia macam layu. Okay, so because of what? There is no net tendency for water to enter. So that's why plant cell become flaccid. Okay, kalau kita tengok dari segi karakteristik of plant cell, dia mesti kena simpan air. Kalau misalnya tak ada berlakunya no net tendency for water to enter, water masuk lepas tu water akan keluar. So what happen to the plant cell? Lama kelamaan dia akan menyebabkan plant cell tu untuk jadi flaccid. Okay, tapi kalau kita bezakan dengan animal cell looks normal. Okay. And then the last solution are hypertonic. So what is hypertonic? It is refers to the solution that has high concentration of solute. So bila concentration of solute ni adalah tinggi, so means that it is refers to the solution where its solute potential is high while its water potential is low. Macam yang saya katakan tadi, water potential of the solution is depends on the present or it will depends on the concentration of solute. Kalau solute tinggi, okay, kalau dari segi concentration of the solute tu adalah tinggi, so maksudnya apa yang akan berlaku? Water potential of the solution is lower than water potential of cell. Okay. So, what happened? Water from cell diffuse out into solution by osmosis. Because of what? Okay, contohnya ni adalah hypertonic solution. Okay, awak letakkan red blood cell di dalam hypertonic solution. Hypertonic solution ni maksudnya adalah solution that has high concentration of solute. So, bila solute dia tinggi, so maksudnya water potential dia akan jadi rendah. So, what happened? Water from cell, okay, will diffuse, okay, into the solution by osmosis. Why? Because the water potential inside of the cell is higher than water potential in the solution. So, kalau kita relatekan balik dengan konsep osmosis, so water will move from high water potential to low water potential. Okay, so that's why, okay, kalau awak compare in between plant cell and animal cell, bila kita letakkan plant cell and animal cell in hypertonic solution, so what happened? Plant cell is plasmolyzed because of what? Water from the plant cell will diffuse out, okay, into the solution by osmosis. So, it will cause the plants to wilt and can lead to plant death. Sebab air keluar. So, terms dia kita katakan sebagai plasmolyzed. Okay, that one is for plant cell. But for animal cell, okay, so what happen when you place the animal cell inside of the hypertonic solution? So, the concept is same. Water from the cell will diffuse out into the solution by osmosis. So, what happened to the animal cell? Animal cell will crenate or shrivel. Shrivel ni maksudnya bentuk macam ni lah. Okay, so this is about types of solution of different concentration.